Well, I believe everyone knows everyone was this morning here from NVIDIA and Southern California as well, and Hiro, who was the chair from yesterday's session, and one shot in the radar exploration for JPL. Thanks for joining. So, I guess one of the first questions that I have is, well, I feel like you touched a little bit on that, but what are the critical steps needed to bring down those costs, achieve economies of scale, and as you say, commoditize, right? Space robotics, similar to those that we've seen realized over the last decade on the small sats industry, right? Where we've seen a dramatic decline in the cost, and therefore, like, the skies are being opened to new companies. Do you think achieving, and this will be a question that for all of you, but would achieving those economies of scale primarily be an industry-led, and if so, what is the role of government, for example, NASA in particular, right, to enable or accelerate this process? When do we start?
Yeah, sure. My short answer is probably we can use AI as much as possible. A very trivial answer. The reason is I saw the previous presentation, and I saw the very common problem is the operation, right? Teleoperation of those robots. So if you can use the AI to reduce some operation costs in the middle, so there will be a huge cost reduction. And I think that's probably a very straightforward way to use AI. For example, you can use AI to you can train some algorithms from those teleoperated data and try to basically do some predictions along with the human teleoperator. Try to basically, if at the beginning you need probably 2 teleoperators, but once you have some AI algorithms deployed in the middle, where you can reduce 2 operators to 1 operator, and then moving forward you can reduce even more. And yeah, that's my short answer. And also, I feel there are lots of common in space robots and some household robots. For example, again, going back to the teleoperation case, it's basically the same problem when we do household humanoid robot, right? So if we can basically transfer the same technology from all the robots on Earth to some space robots, I think that can also reduce some development cost. Yeah, that's my answer.
How about you, Hiro?
So to achieve the economies of scale, we need scale. And to achieve scale, we need demand, right? So where the demand comes from, it seems to me still fuzzy, Now, I know that many companies are excited about water on the moon. I'm excited. But I also personally think that the community is overexcited about the industrial potential of water on Mars, on the moon. Water on the moon, unlike Mars, is very scarce. We don't know if the water is exactly like water, it's just hundreds of minerals. No one knows. No one knows if it's really, exploitable. Even so, the volume is super limited. Not really. So I don't know. Personally, people are all talking about serious scientific or profitable applications. I would love to see non-serious applications, right? For example, on CubeSats, my favorite, there is a Japanese temple somewhere who wants to put Buddha in space, and that's the whole point of CubeSat. And there's a hobbyist just making CubeSat for no reasons. I wonder if as the cost goes down, so it's unique, but those non-practical applications could have some potential to increase the volume.
So there's 2 areas that are known demand areas. So payloads are a real industry. It has a GDP to it. There's current industry that's existing where they're putting it on ISS National Lab. There's a demand where there's more payloads than there are providers. There's a response to that for now payload operators to go on orbit. There will be shortly destinations. I don't think CLDs are the right, but a payload platform where something like a Zephyr or a Varda can go to and deliver things, pharmaceuticals, different manufacturing techniques. The pharma industry is actually very interested in this, or have very deep pockets, right? So this is a real industry. So what are you going to need to enable that? I need the destination, I need the launch vehicle, and I need the thing to be able to touch the two together, which looks a whole lot like a robotic system. You add companies like Max Space that has atmosphere. You don't need the full inflatable, something the size of a volleyball that can then you take whatever the delivery payload is and it can go into that atmosphere and grow your cells. That industry is real, and it's something that can be responded to and is being responded to now that robotics has a place in. The second industry, so robots, other than that application, we've struggled as an industry to figure out where robots apply in LEO, because the launch cost to get something into space is so low, going and servicing it or poking at it in LEO just doesn't hit the economic curve. So where are robots applicable at? Well, they're in remote operations, MEO and GEO primarily. The current class of satellites that you want to go and service were never designed to be serviced. So there's about 600 satellites that MEO and GEO will need over the next 10 years. So if you're going to invest in the next 10 years, where you're going to go service a satellite, I'm not going to come up with the solution to go service the things that were never intended to be serviced. I'm going to go spend that time working with the next generation of satellites to ensure that they're serviceable. And every one of those satellites should be launched with a robotic arm so that it can now receive payloads, much like we have experience with ISS. ISS has the arm, it is the destination, and we send assets to it, and then it grapples and then reprovisions. Those are the two areas where there's an economic structure that closes. Other than that, I'm unaware. I'm sure there's someone that's been thinking about it, but those are the only two I know of.
And following up on the role of government and NASA to enable that, where do you guys see the kind of the opportunities, or especially as now the agency is going through kind of an inflection point right now, right? What could be the role of NASA to enable that moving forward, right? Maybe Hiro.
As the NASA representative.
So there are multiple ways, right? One is simply to start this chicken and egg engine. But I think that's the whole point of Artemis. NASA dropping huge amount of money to do something on the moon, and industry goes there to capture that business opportunity and use that technology to do something else. So starting igniting the engine, that's one. And the other, kind of a little bit ironic at this point. As you saw the news, many thousands of employees leaving NASA, and another layoff's gonna come to JPL soon. So expect my job applications to your company soon. But thinking positively, right? NASA people have a lot of experiences in flight and space and exploration that kicked out thanks to Elon Musk and Trump, and then goes to commercial. That's personally, it could be a tragedy, but industrially, maybe that's a good thing, right? So.
Well, switching gears, actually, I want to double click on what you said about AI. You were talking about this sort of like flywheel effect, where at least the way that we've seen right now in AI companies and also robotics and AI companies, where they're trying to collect new data. They obviously use more simulation as well, but it's always been as opposed to like the big AI tech developers where they can be fed like these models with internet data. In robotics, you have that data bottleneck when you need more and more examples of that, right? How do you see that translating into space, right? Into space robotics, like where, as you said, like because of the latency and lack of communication, especially like teleop doesn't work that well, right? There seems to be like a really critical need, right? But in the other sense, like we've been talking about, like it's hard for industry to maybe bring in AI talent, right? Because all the big tech companies suck the talent because they can pay more, right? And obviously for government it's even harder, right? To bring in AI talent. So do you see more like on one side, like do you see maybe like at some point big tech getting into space, maybe once it's starting to become like maybe we have Starship or like more like open, or do you see like the path for this industry? I'll give you both, of course. The path for those startups and space industries would be like more collaboration.
Mm-hmm.
The same with NASA, right? More collaboration with big tech, right? Like the Googles, the OpenAIs, etc.
Yeah, I think that's a good question, and I think that's a real issue that all the AI companies just pull all the great talents, but at the same time they develop some softwares that can be used by everybody, right? For example, if you are doing a lot of coding nowadays, you might use a cursor or some Lovable or other tools that can what they call the vibe coding, so that can help you build something that's like within hours that will probably before you just you need to spend the days or months to build the software. So I think so basically my short answer is probably with nowadays with all the great AI tools we can also accelerate the development of many applications in the space robot domain. So for example, coding is made much faster than ever before. I think that's the same thing in space robots. And at the same time, for example, I will take the teleoperation as the same example. So teleoperation, if you look at all the developments in those robotic companies, we can probably use the same technologies in those space robot domains. So I would say, so the issue is real. So we those AI robotic companies indeed take all the talents, but at the same time, all the technologies can be transferred into different domains, including space robots, including other domains. So yeah, I think so moving forward, we definitely need to like educate more AI talents and also try to basically bring AI into different domains. At the same time, I think for different applications, we can try to leverage state-of-the-art AI tools to accelerate the development in different fields.
Let me write on this AI topic actually inject my thought. You know, the current an explosion, someone called it Cambrian explosion of AI and robotics, is partially owing to open source culture, right? You know, unlike anything else in the past, like any AI researchers like UA, you know, publish papers and then put their code on GitHub, right?
True, yeah.
And put their data set public so that, you know, you can easily reproduce others' result on your own environment. You can use it as a third-party software and build up on it. Even that propagated hardware, like these days, roboticists publish their hardware design on GitHub so that anyone can download it and 3D print to recreate it. So this open source culture exponentially accelerating the innovations. And this is something that's often like, you know, underlooked when we talk about, you know, all the hypes of AI. This open culture has not propagated to space. For one thing, yes, we, NASA or whatever companies, ITAR, we cannot just, you know, if I put my Mars rover code on GitHub, of course CIA gonna be after me, so I cannot do that, right? So, you know, the question is how to replicate that kind of thing in space, which I don't know.
Well, I think we don't have more questions. Brice needs to catch a plane, but
yeah, gotta catch a plane. You guys keep going, have fun. Thank you so much for.
Well, please give it an applause. We'll share.